In the following video, I would like to discuss the use of two important analysis calculations as part of any temperature uniformity survey, as provided in the Thermal View Survey software from Phoenix Temperature Measurement. In AMS2750, there is a clear defined list of requirements for the heat treat engineer to achieve as part of any temperature uniformity survey. The TUS pass-fail requirements, as you can see on the screen at the moment, are very clear and concise. But it's important to remember that some occasions you need to combine the specific requirements of the AMS2750 with other associated standards that may be relevant to the material or the processing that you're performing. As it states here, a key requirement of the AMS2750 is the provision of evidence that the time required to achieve TUS sensor temperature recovery, stabilization, or a recurrent temperature pattern shall not have exceeded the time limits specified in the applicable material or process specification. This isn't actually quantified in the AMS2750 standard itself, but other standards will have this information or this requirement listed. A good example of that is AMS2770, which is used for monitoring the heat treatment of wrought aluminium alloy parts, where the recovery and stabilization times are critical to the success of the heat treatment step itself. If we look at AMS2770 in detail, in section 3.1.2, which relates to the monitoring or the temperature uniformity survey of the furnace itself, there is specific requirements for both recovery time and also an analysis called lag time. As you can see here, it says that as part of the temperature uniformity survey, for the recovery requirements of the process, the lag time between recovery of the first thermocouple and the last thermocouple reaching the tolerance limits has to be within a certain duration. And it states specifically for a furnace tested without a load, that lag time should be less than 20 minutes. And for a loaded furnace, that lag time will need to be shown to be less than 40 minutes. In the same standard, there is specific requirements for certain materials, for instance, as stated here for alclad parts. For solution heat treating of parts made from alclad, products under 3.18 millimeters thick, the furnace recovery time shall not exceed 30 minutes, and for parts made from heavier alclad product shall not exceed 60 minutes. So we are being requested to quantify two key parameters, recovery time and also lag time. So that's what we're trying to achieve with a new analysis feature within the software. So let us just confirm that we fully understand what the difference is between recovery time and lag time. The definition as part of the standard is for recovery time, the elapsed time between the insertion of parts in a heating medium and the start of the soaking time. So in essence, if we look at the little schematic we have of a TUS being performed at a temperature uniformity survey level of 500 degrees Fahrenheit with a tolerance of plus or minus 10 degrees Fahrenheit. The recovery time is the time between the insertion of the part, so time 0, and the point at which each thermocouple reaches the minimum tolerance. So for thermocouple 1, 2, and 3, the recovery times would be T1, T2 and T3. The slowest recovery in this particular case is for thermocouple number 3, and that would be the defining recovery time as part of the standard. The lag time, as defined in the standard, is the time difference between the recovery of the first test thermocouple and the last test thermocouple to be within TUS tolerance. So in our example here, the lag time is delta T, which is basically the difference between the time for thermocouple 3 and thermocouple 1, the green and the red thermocouples, to reach the minimum tolerance limit of the TUS level that's being monitored. Within the thermal view survey software from Phoenix Temperature Measurement, we obviously provide all of the TUS data for each of the thermocouples approaching the TUS level and proceeding through the overshoot search, the stabilize and the TUS time. We can manually measure the recovery time in historic software packages and manually calculate the lag time. But we've now incorporated within the software the ability to automatically analyze the data and report it as part of the TUS analysis package. For any analysis in the software, it's obviously important to ensure that the start of the process is synchronized. So the oven start time, the time zero time, has to be adjusted to the start of the ramp up of the thermocouples as the product or the load is entered into the furnace. And this is done in the conventional way using the oven start and stop correction feature. But it allows you to accurately adjust that time reference for the start of the TUS against which the recovery times and the lag times will be measured and calculated. Within the TUS results table now, there is the ability to select, in addition to the standard analysis features, recovery and lag time by clicking on the recovery and lag time checkbox in the header of the TUS results table. This will automatically then generate at the bottom of the table the analysis of both recovery time and lag time. The recovery time is quantified and reported for each separate thermocouple that was used in the TUS level, and we highlight the quickest in blue and the slowest in orange. So you can see the blue one at 36 minutes and 20 seconds is the first thermocouple to reach the minimum TUS, and the slowest thermocouple is thermocouple 5, which took 1 hour, 10 minutes and 30 seconds. From that data, we can therefore calculate the time difference between the slowest and the fastest, and that gives us a lag time of 34 minutes and 10 seconds. Just to reiterate how the analysis is performed. So the fastest recovery time is the first thermocouple to reach the minimum TUS limit. The slowest is the last thermocouple to reach the minimum TUS limit, and the lag time is the time difference between those two separate events. But it's automatically calculated and reported in the table for you. So the only thing you need to do is to adjust the oven start to ensure that you've got consistent data reference in terms of time for when the product was loaded into the furnace and the survey was started. The analysis that is shown in the software is then duplicated in the comprehensive TUS report that will be as part of your validation package to prove compliance to AMS2750, or if you're doing work with aluminium, AMS2770. And you can see here that as part of the TUS analysis, we now report the recovery and lag time as part of each and every TUS level. Just to note that the recovery time is only reported for the first TUS level, but the lag time is reported for the first and subsequent TUS levels that are performed if you're doing multiple levels as part of your TUS. So let us now investigate how we can apply both recovery and lag time analysis within the Phoenix Temperature Measurement Thermal View Survey software. On the screen at present, we have a single TUS level analysis result at 800 degrees with our plus or minus tolerance band of plus or minus 14 degrees. The TUS level has been satisfactorily achieved within tolerance to give the color bands of the overshoot, search, stabilize, and TUS time, and the analysis to quantify the results of the TUS at that level. You'll notice though that we now have the ability to select, in addition to the conventional analysis data that you've been used to, the calculation of recovery and lag time. Before we switch that on, let's remind ourselves that an important aspect of this calculation is ensuring that we've got a common or accurate time reference against which the recovery times are calculated. This is obviously the point at which the product enters the furnace. Now you'll notice on the profile at the moment, the time reference for the zero time is corresponding to the first data point, which doesn't reflect when the product entered the furnace. We therefore have to correct that. The easiest way to do that is to go to the top right hand corner of the software, and we're going to look at the oven start stop feature that we have discussed in previous videos. The green oven start and the red oven end cursors allow us now to manipulate the time reference to show where the true zero time, the point at which the product enters the furnace, is being used. In order to do that, the easiest way to do it is to take the green cursor and to drag it to the necessary point on the data. If you need to, you can zoom in to make that even more accurate. So I'm going to do that. So I'm going to bring it to the point where the temperature goes from the ambient of 20 and starts to rise, and click OK. Okay, at the moment we're missing the end part of the TUS level, so I'm just going to change that. I'm just going to move the end cursor to reflect the full TUS level 1. And you'll now notice that for the profile zoom, we have a corrected oven start, and we're seeing all of the data for the TUS level at 800 degrees. If I now activate the recovery and lag time analysis by simply checking the analysis feature button, you'll notice at the bottom of the analysis table now we have the calculated recovery time and lag time for that first TUS at 800 degrees. The recovery time for each one of the thermocouples is quantified and reported. The quickest thermocouple to reach the tolerance band is listed or shown in blue, and the slowest is in orange. So if you're trying to achieve a designated or required recovery time, you'd always ensure that your slowest recovery time is less than the required specified time in the standard, whatever that may be, relevant to the material you're processing. From this data, we can then calculate the lag time, which, as we've described before, is the difference in time between the slowest, the orange, and the fastest, the blue thermocouple. So in this case, the difference between 1 hour and 11 minutes and 36 minutes and 50 seconds, which is 34 minutes and 10 seconds. So we have fully quantified both the recovery time and the lag time for this first TUS level. Having done the analysis, you'll note that if we go to the print TUS report, if I go to setting up the TUS report, you'll notice now that on the analysis table, you can see that in addition to the conventional analysis results, we now are replicating the recovery time and the lag time results that we calculated as part of the TUS routine. So this is fully documented and would allow you to prove to an auditor that you've achieved the necessary requirements against the standard that you are performing your TUS routine. So there we have the opportunity now to complement the traditional TUS analysis criteria of the thermal view survey software with both recovery time and lag time efficiently, quickly, but also accurately.